Hello everyone, welcome back to AI for Product Managers, episode 3. Last time we covered the AI product lifecycle and why your agile process breaks down with AI, right? Today we are tackling something even more important, like how to communicate with your data science team. Okay, here is a stat that should worry you. 62% of data scientists says their PM does not understand their work. Okay, and 45% of AI project delays comes from the miscommunication between the PMs and the technical teams, right? Not from the bad models or not from the bad data, from the people talking past each other. Okay, the good news is this is fixable. In the next 30 minutes, I am going to give you the exact vocabulary, the right questions to ask, the questions to never ask, and the real conversation scripts you can use in your next meeting. So, by the end of this episode, your data scientists will notice the difference. So, let's go. So, here is what we are covering today in this session the 20 key terms every PM must know with plain English translations, questions that earn respect from data scientists, questions you should never ask and why they damage the trust, right? So how to run productive meetings with ML teams, and three real conversation scripts for common scenarios you'll face. Okay, so this is the most practical episode so far. Everything here is something you can use tomorrow. Let's start with the gap. Yeah, so let me show you what the communication gap actually looks like in practice. Okay, so when a PM says, can you make it more accurate? What the data scientist here is, I don't understand that accuracy has trade-offs, right? More accurate at what cost? More precision means less recall. More recall means more false positives. It's never just make it better. Okay, so when PM says when will the model be done, the data scientist hears, I think this is like building a feature with a predictable timeline, but AI experiments don't have predictable outcomes. Okay, the model might never hit your target. That's a valid outcome. Okay, and when a PM says just use AI for this, then the scientist hears like, I have no idea what AI actually does or what's involved. It's like saying build an app for this to an engineer. So it reveals a fundamental misunderstanding of the work. And when a PM says, why is it taking so long? The data scientist hears like, I don't value the experimentation process. Okay, they might have run 5 experiments, each teaching them something crucial, right? That's not wasted time. That's the scientific method. Okay, the fix is not to become a data scientist, it's to learn enough vocabulary and ask the right questions so you can have the productive conversations with them. So let's start with the vocabulary. So I'm going to give you the 20 terms organized into three groups. You don't need to memorize the definitions. You need to understand them well enough that when your data scientist uses them, you can follow the conversation and ask intelligent follow-up questions. Okay. In the group one, data and training terms. The training data, the examples you feed the model to learn from. Okay. Think of it as a textbook. The more examples you give, the better the model learns. Okay, but the quality matters more than the quantity. Okay, and test data, held out the data the model has never seen. Okay, used to evaluate the performance. This is the final exam. If you test on the same data you trained on, you are cheating, right? That's called the data leakage. And labels, the correct answers attached to the training data. If you are building a spam detector, labels are spam or not spam on each email, right? Someone have to create these, and that's often expensive as well. Okay, and coming to features, The input variables the model uses to make predictions. Think of them as columns in a spreadsheet. For a churn model, features might be in days, right, since the last login. But number of support tickets, subscription tier, all comes into the matter. Overfitting. When the model memorizes the training data but fails on new data, like a student who memorizes the textbook word for word but can't answer a question phrased differently, right? This is one of the most common problems in the ML. Okay. Underfitting, the opposite side of overfitting. The model is too simple to capture the patterns. Like a student who did not study enough, right? Usually means you need more features or a more complex model. Okay. Epoch. One complete pass through all the training data. Models typically train from many epochs. Think of it as reading the textbook cover to cover once. Okay. You might need to read it 50 times to really learn it. Okay. Yeah. And the group two, metrics and performance. Precision. Of all the things the model flagged as positive, how many were actually positive, right? When a model says this is fraud, how often is it right? High precision means few false alarms. Okay, mind it. And recall. Of all the actual positive cases, how many did the model catch? Of all the real fraud transactions, what percentage did we detect? Okay, high recall means we miss very few real cases. Okay, these two are in tension. I'll explain the trade-off in detail in few minutes because it's the single most important concept of PM to understand. Okay, the F1 score, the harmonic means of precision and recall, one number that balances both. Useful when you need a single metric but care about both false positives and false negatives. Okay, AUC or ROC curve. Okay, a measure of how well the model discriminates between classes overall. Okay, think of it as like how good the model at separating the good from the bad. Okay, across all possible thresholds. zero point 0.5 is the random guessing, 1.0 is the perfect. Okay, think about make it noted. And latency, how long it takes to return a prediction. If your model takes 3 seconds to respond, that might be fine for a batch job but terrible for a real time user experience. Okay, inference, running the trained model on a new data to get predictions. Training is nothing but learning, right? Inference is answering the questions. Training helps once or periodically, but inference happens every time a user makes a request. Okay, hyperparameters, settings you configure before training starts, learning rate, number of layers, batch size. Think of them as a knobs on your mission. Okay, on the mission, the data scientist tunes these to get the better performance. Okay. Group three is architecture and operations. So pipeline, you might heard about pipeline, right? In tech terms, the end-to-end flow from raw data to productions. Data comes in, gets cleaned, gets transformed, feeds the model, and finally the prediction comes out. Okay, if any step breaks in between, the whole thing should break. Whole, the whole thing will break, obviously, right? Fine tuning. Take a pre-trained model and adapting it to your specific task. Okay, instead of training from scratch, you start with a model that already knows language or images and teach it your specific domain, like hiring an experienced chef and teaching them your restaurant's menu. Okay, and embeddings, numerical representation of text, images, or other data. Right, the model converts words into coordinates in a mathematical space where similar things are close together. King and queen are close, right, in chessboard, but king and banana are far apart. So that's the difference. Batch versus real time. Do you process the data in bulk overnight or an on demand job for each request? Batch is cheaper, but it is stale. Real time is expensive, but it is fresh. The right choice depends on your use case. Okay. Modal drift. When model accuracy degrades over the time because the world changes, like skills getting rusty, right? User behavior shifts, new patterns emerge, and the model's training data becomes outdated. The ground truth is the actual correct answer you compare predictions against. Okay. To know if your model is right, you need to know what right actually is. Sometimes getting ground truth is the hardest part of the whole project. Okay, keep it in mind. So that's your 20 terms. You don't need to use them all in the conversation, but when your data scientist says we are seeing overfitting on a validation set, or precision is high but recall is suffering, you will know exactly what they mean. Okay. Yeah, now let's talk about the questions. The right question signals the competence, right? The wrong question signals the ignorance. So here are some 7 questions that will immediately earn some respect from your data science team. So number one, what's our precision recall trade-off here, right? This shows you understand there is always a trade-off. You will not naively ask for better, right? You're asking which direction to optimize. The second question is like, what does the confusion matrix looks like? This shows you care about the types of errors, not just overall accuracy, right? A model that's 90% accurate might be terrible if all its errors are in one critical category. Okay. And the third question is, how much label data do we need to hit some X percentage, right? This shows you understand the data requirements and you're thinking about the investment needed. It also opens a conversation about whether the target is realistic or not. Okay. The question four, what's the baseline we are trying to beat? Okay. This shows you think in terms of improvement over the status quo, right? Not the absolute numbers. 80% accuracy sounds bad until you learn the baseline is 50%. Okay. And number five, where is the model failing? Okay. Any patterns in the error? This is the gold one. Okay. It shows you want to understand the failure modes, not just celebrate the successes, right? And it often reveals the product insights. Maybe the model fails for a specific user segment that needs different treatment. Okay. And the question six is, what would you need to improve this by some 5 percentage points, right? So this shows understand that improvement has diminishing results returns. Going from 70 to 75% might take a week. Going from 90 to 95% might take 3 months also. Okay. You're asking about the effort to gain the ratio. Okay, keep it in mind. And question seven, how will we know if the model degrades in production? Okay, this shows you are thinking beyond the launch. You understand that AI is not ship and forget, right? It needs monitoring. Your data scientist will love that you are thinking about this proactively. Now, till now we discussed about questions that earn respect and questions that should ask. In the next slide, we'll discuss about questions that never ask. It's a flip side, the questions that damage your credibility as well, right? I'm not saying these to shame anyone, but I have heard brilliant PMs ask all of this. But once you know better, you do better. Okay. Never ask, can you make it 100% accurate? Okay. Instead of ask, what accuracy is realistic given our data? 100% accuracy doesn't exist in AI at all. Okay. Asking for it shows you don't understand the fundamental nature of probabilistic systems. Okay. And never ask, why can't you just use more data? So instead of ask, what's limiting our performance right now? More data is not always the answer. Sometimes it's data quality, sometimes it's the wrong features, sometimes it's the model architecture itself. Let's the data scientist diagnose the problem. Okay. And never ask when will the model be done. Instead of ask what's our confidence level for hitting the target by date X. Okay. A experiment don't have deterministic timelines, and frame it as a probability, not certainty. Okay. Never ask, can you explain it in simple terms? This sounds condensing. Instead of say, help me understand the key trade-off here. So you are asking for same thing, but positioning yourself as a partner, not as a student. Okay. And never ask, just make it work like chat gpt. So instead ask what architecture is best for our specific problem. Chat gpt is like a specific model for specific purpose, right? Your problem might need something completely different. So this question reveals you think all ai is the same. Okay. And why is this taking so long? Instead ask, what's blocking the progress? How can I help unblock? The first is accusatory, the second is some collaborate the second is like collaborative, the same information which is completely different relationship dynamic. Okay. Now let me spend couple of minutes on a single most important technical concept of for pms to understand the precision recall trade-off. Once you get this, you can have some intelligent conversations about any AI model. Okay, so imagine you are building a fraud detection system. You can tune the model to be more aggressive or more conservative, right? So high precision, low recall means when the model flags a transaction as fraud, it's almost always right, but it misses a lot of actual fraud, right? It's conservative. So only flags when it's very sure. Use this when false positives are expensive. So a spam filter should have high precision because flagging a real email as spam means your user misses something important. Okay. So high recall and low precision means the model catches almost every real fraud case, but it also flags a lot of legitimate transactions, right? It is acting as an aggressive. Flags anything as suspicious. Use this when false negatives are expensive. Okay. Fraud detection should have high recall because missing real fraud costs thousands of dollars, right? So you can have both at 100%. That is called trade-off, right? And here is the key insight: deciding which side to optimize is a product decision, not a technical decision. The data scientist can build either. Okay. Your job is to decide which matters more for users and your business. When you walk into a meeting and ask, what's our precision recall trade off here, you have just signaled that you understand the fundamental challenge of AI systems, right? That ends instant respect. Yeah. So now let's talk about the meetings. So most PMs, DS or data scientist meetings are status updates, like that could be a Slack message. So here is how to make them actually productive. You need four types of meetings with your data science team. First, a weekly sync, right? The 30 minutes max. What experiments ran this week? Any blockers? Any decisions need from me? So keep it tight. If there is nothing to discuss, just cancel it. And second is experiment review, 60 minutes. After a major experiment completes, deep dive on the results. What did we learn? And what's the next hypothesis? Do we continue, pivot, or ship? Okay, this needs to be discussed. And third, the data review, which comes around 45 minutes, especially early in the project. What's the data quality? Any gaps? How is labeling progressing? This is where most projects get stuck, right? So give it a dedicated time for them. And for the threshold decision meeting, which comes around 30 minutes, when a model is approaching your target, is it good enough to ship? What's the risk? And what's the plan if it degrades? The golden rule for all of these is like every meeting ends with either a decision or a clear next experiment, right? If you leave a meeting without one of those, the meeting was wasted, right? So no status, only meetings. Like status goes in Slack or your project tracker. That's it. Now I'm going to give you three conversation scripts for every scenarios, every AAPM phases, right? These are based on real conversations I have had. Use them as templates. Okay. The script one, the project kickoff. So you are starting a new initiative. Here is how to frame it. So you say, here is a business problem. Users are churning with 30 days. We want to predict who is at risk so we can intervene early, right? Notice that you are leading with the business problem, not a technology, right? And then our baseline is a rule based system that catches 40% of churners. We need to beat that significantly to justify the investment. You have set the bar over there, and the data scientist knows what success means now. Okay, then what data would we need? What accuracy do you think is realistic? And what's your confidence we can get there, right? You're asking for their expert opinion. You are not prescribing the solution. Now, the data scientist might say, with 6 months of behavioral data, I would estimate we can hit 75 to 80% of recall. Like I would want to start with a simple model and iterate, right? Then PM response, great. Let's time box the first experiment at 2 weeks. What is your hypothesis for the first approach? You have set a time boundary and asked it for a testable hypothesis, right? That's the experiment driven development in action. So this is about script one. Coming to script two, um, disappointing results. The experiments didn't hit your target, right? So the data scientist says the model is only hitting 68% recall, below our 75% target. Then PM should not panic, right? Don't say why not. Um, Instead, say, okay, so help me understand, where is it failing? Is there a pattern in the errors? You're diagnosing, right? You're not blaming them. And they might say it's struggling with users who have less than 2 weeks of history, not enough signal. Now, you can problem solve together, right? Got it. Okay, you can say got it. Two options. We could exclude new users from predictions, or we could add more features for the segment, right? For that particular segment, why would you try next? So they suggest adding features, right? You say let's time box one experiment at 1 week. If we still can't hit the 75%, we ship at 68% for established users only and iterate, right? You made a decision, you set a boundary and defined a fallback plan as well. That's the PM leadership here. Okay, skip three. And defending your team, right? A VP is pressuring you on the timelines. So VP says, why isn't the AI feature shipped it? It's been already 6 weeks. You can say, um, we have completed the three experiments. The model is at 82% accuracy, up from our 60% baseline. We are targeting 85% before the launch. So you are showing a progress, not making the excuses here, right? Then the team discovered a data quality issue in week two that would have caused production failures. Fixing it added a week, but saved us from the bad launch. Right? You're framing the delay as a risk mitigation here. Okay, and then we have one more experiment running. Decision point is Friday. Ship at 82% or invest one more week for 85%. So I'll bring the recommendation. You are giving a clear timeline and decision point. So if they push on the ROI, right? Um, 82% saves is approximately 2 million per year in fraud. 85% saves 2.4 million, right? The extra week costs about 15K in engineering time. So clear ROI to try, right? Numbers win the arguments. Always translate model performance into the business impact. Now, before we close, let me talk about the relationship itself. So, technical vocabulary gets you in the door, but trust is what makes the partnership work long term, right? Five principles to build for building the trust with your data science team. One, respect their expertise. Don't tell them how to build the model. Tell them what problem to solve and what success looks like. Okay, they are the experts on how. And you are the expert on the what and why part. Okay, keep in mind scientists are experts on how part, you are expert on why and what part. Okay, and two is like protect their time. Data scientists hate unnecessary meetings. Okay, be the buffer between the stakeholders and the data science team. Filter the noise so they can focus on their work. And three is like celebrate the experiment, not just the wins. Okay, a failed experiment that saves 3 months of going in the wrong direction is more valuable than a lucky success. Okay, acknowledge that publicly. And four is like translate, don't oversimplify. Learn enough to translate the data scientist findings into the business language without dumbing it down. Okay, and when you present their work to the stakeholders, preserve the nonce. Don't say the AI is 90% accurate when the reality is more complex. Okay, and five, give them some business context. Okay, data scientists work better when they understand the why part. Okay, share the user stories, share the revenue impact, share the competitive pressure. Context makes their work more meaningful and their solutions more relevant. Okay, so and quickly, I would also want to share some cheat sheet, what to say in common scenarios like data scientist says model is ready, then what's the failure mode? Show me the worst case predictions. Stakeholder wants it faster. Let me check with the team on what we would trade off for the speed. Okay, model accuracy platelets. Is this a data problem or a model problem? What would move the needle? Okay, DS proposes complex approaches. Like, which is the simplest version we could ship first and iterate. These are all the answers you have to give for these questions. Okay, results are confusing. Walk me through one example. Predictions end to end. Team disagrees on the approach. Let's time box both approaches for 1 week and compare. And finally, the data scientist is frustrated. What's blocking you? What can I take off your plate? So these are some common cheats you can represent during your conversations with data science team. And coming to and quickly the anti patterns also I want to discuss things that destroy the trust fact, right? Micromanaging their technical choices, making timeline promises without consulting them, dropping the buzzwords you don't understand. Okay, asking for daily progress on a 2 week experiment, adding scope in the mid experiment, right? That is one thing, and taking credit of their work without naming them. So avoid all of these things. Okay, and finally, homework time. Three things before episode 4, right? One, pick 5 terms from today vocabulary slides. Use at least one in your next meeting with your data science team, not to show off, to show you are investing in understanding their world, right? Two is like in your next data science sync up meeting, ask one question from the questions that earned respect slide. My favorite starter is like, where is the model failing, and any patterns in the errors. Watch how the conversation changes, right? That is one thing. And third one is, if you are starting a new AI initiative, use script one as your template for the kickoff meeting. Lead with the business problem, set the baseline, ask for their expert opinion on what is realistic. And yeah, so the next episode, in episode 4, we are covering supervised versus unsupervised versus reinforcement learning from a PM perspective. You will learn when to use each type, the cost and data implications, and real decision frameworks. It's going to make you dangerous in the technical discussions. So one thing I want to ask, if this episode was valuable for you, so please subscribe, hit the bell, and drop a comment. So this gives me more encouragement. So for the further episodes. So what's the hardest part about working with data scientists for you? Add that in the comment. I'll address the top questions in a future episode. Okay. And the key takeaways from this slide is like, learn the vocabulary. You don't need to explain it, just understand it, right? Ask questions about trade-offs, not timelines. Your job is to define the problem and success metrics, not the solution. And protect your data science team's time and celebrate the experiments. Translate between business and technical, um, right? So that's your superpower. So the best PMs don't pretend to be data scientists. So they are the bridge between the business problem and technical solutions. Okay. Thank you. I'm Pranav. This is AI for Product Managers. I'll see you in the episode 4. Thank you all.